Hi class, this is section 11.3 of your book, Dependent and Independent Events. The objective for this lesson is to determine the probability of an independent event and dependent event. So first we'll talk about some vocabulary, and the first thing we're going to talk about are independent events. That means if the probability of one thing doesn't affect the probability of another thing. For example, if I were to flip a coin one time and it lands on heads, when I flip it the second time, it doesn't matter what happened the first time. The second time would be independent. So that's all it really means. Um, so events are independent if one does not affect the other. And we'll go over some examples of that. Go back and use this formula here, and all you do is, if you have two independent events, you multiply to find the probability of them happening together here. Is just to multiply each of the probabilities of the independent events together. So let's look at the example number one, and it just says um, find the probability of each independent event. Okay, so let's look at what it says. It says a six-sided cube is labeled with the numbers 1, 2, 2, 3, 3, and 3. Four sides are colored red, one side's colored white, one side is yellow. Find each probability. Well, the first one, it says, what's the probability of tossing a 2 and then tossing another 2? Now, these events are independent because the first roll that you make has nothing to do with the second roll that you make. Now, to figure out what the probabilities are of these two things happening together, we'll use that for this one. So what's the probability of first rolling a 2? Well, if you look at the cube, there are two 2's on the six-sided cube. So the probability of rolling a 2 the first time, and I'll call it 2 first time, is going to be equal to 2 over 6 because there's 6 possible outcomes. 1, 2, 3, 4, 5, 6. And there's 2 events that can be a 2. So that's 2, or you could call that, just to simplify the fraction, you call it 1/3. Now, what's the probability of rolling a 2 the second time? Well, really, it's the same probability, right? One doesn't affect the other, just 1/3. So the probability of both of them happening together, you have to multiply them together. So to find the probability of them happening together, the probability of rolling a 2 the first and second time is going to be equal to 1/3 times 1/3, and that's equal to 9. I'm sorry, 1/9. So that's the answer here, 1/9. All right, let's look at part B. Part B is saying, what's the probability of tossing a red, then a white, then a yellow? Okay, let's look at the probability of each. The probability of red is equal to, well, there's 4 sides colored red out of the 6, which is going to be 2/3. So 2/3 probability of rolling a red. White has one side and yellow has one side. So the probability of white and the probability of yellow are the same. And that's just 1/6. And that's 1/6. So the probability of rolling a red, then a yellow, then a white is going to be their probabilities multiplied together. So that's going to be probability of red times probability of white times probability of yellow, and that's equal to 2/3 times 1/6 times 1/6, and that's equal to 2 over 108, or 1 out of 54. All right. Okay, now let's look at dependent events. Now that's a little bit different than independent events. And you have to think about this a little bit more first. But let's just take this example of you have one lime and two lemons put into this bag. There's three things put into the bag. So the first thing that you pick out would definitely affect the second thing you pick out. And that makes those events called dependent, because the probability of the first thing changes the probability of the second thing happening. So if you had one lime and two lemons in this bag, if the first pick was a lime, then you'd have two lemons left in the bag. So the probability of picking a lemon would be 100% or 1, because there's no limes left. The probability of picking a lime would be 0. Now let's say you picked out a lemon first. This is the first one you pick out. This is the second one you pick out. Let's say you pick out a lemon first. Well, if you pick out a lemon first, then there's a lemon and a lime left in the bag. So the probability of you picking a lemon second would be 1/2, and the lime second would be 1/2. So the probability of the first pick definitely influenced the probability of the second pick. And these are called dependent events. So you can find the probability of dependent events. You can use the conditional probability of event B given that event A has occurred. So if A and B are dependent events, then A and B is equal to the probability of the first thing happening times the new probability of the second thing happening, depending on what first thing did actually happen. And it might sound a little bit confusing, but it's really much easier if you look at these with examples. Okay, so let's look at example 2, finding the probability of dependent events. Okay, so we have two number cubes, one yellow, one white, and it's going to ask us to explain why the events are dependent and find out what the probability of them happening are. Okay, so the first question is, the white cube shows a 6 and the sum is greater than 9. Well, if first thing it says, explain why they are dependent. Well, if the white cube has already rolled a 6 and their sum is equal to 9, greater than 9, then that gives you some indication of what the yellow cube was rolled. So the yellow cube now only has a couple of different possibilities, and the only possibility for the yellow to be rolled would be a 4, a 5, or a 6. Those are the only three possibilities that the sum of these added together would be more than 9. So how many different probabilities of that? Well, so case 1 would be 6 and 4, case 2 would be 6 and 5, case 3 would be 6 and 6. So that's one scenario, two scenario, three scenarios that would make it greater than 9. And so there's only 3 possibilities. And what are the total outcome possibilities? Well, you have 6 chances on the white die and then 6 chances on the second die. So the total number of outcomes would be 36. So the chance of you rolling your favorable outcome would be 3 over 36, and that would just be 1 over 9. So the answer is 1 over 9, and they're dependent because one affects the other one. They have to add together to be above 9. The second problem says the yellow cube shows an even number and the sum is 5. Let's look at the yellow first. So the yellow can only be 2, 4, or 6 because it has to be an even number. And then the white has to be a number that's higher than 5. I'm sorry, the sum is 5, exactly 5. So the white would have to be 3 in this situation if the yellow was a 2. It'd have to be a 1 if the yellow was a 4. and it would have to be well, it couldn't be a 6 because that would be a higher than 5. So that choice is eliminated. So we'll go ahead and eliminate 6. That's not a possibility. So how many outcomes do we have now? Well, we have a 3, we have a 3 and a 2 possible, and we have a 4 and a 1 possible. So it's 2 favorable outcomes we have possible out of the 36. And so the probability of you rolling your favorable outcome would be 1 over 18. So, and the reason why they're dependent is because if the yellow cubes are even numbers, then it limits the number that the yellow cube can be rolled to make your favorable outcome. They're dependent on each other. All right, try these 3 questions, on your own, and turn these in, and we'll turn this in on the video feedback form, just like you normally would. I know I didn't want to give you any homework over the weekend. And then this will be your classwork. And the first answer is independent. Gave you that one. Okay, thank you.